Hi everyone, in this lesson we are going to graph using the mapping rule. So the mapping rule is our xy coordinate is mapped onto, and the general rule is x minus h and then ay plus k. So everything that's horizontal is here and everything that's vertical goes in the y space. Okay, so our key points of our parent function are -2, 4, -1, 1, 0, 0, 1, 1, and +2, 4. So basically what we are going to do is we are going to plug in each of these coordinates into our general mapping rule. So for this one, I should have left a little space here. Our general rule is x, y, and then, so the h, so our vertex is -2, -3. So that's the h and that's the k. Okay, so we're gonna have x minus 2. So when I plug this h of -2 into my formula, the sign, actually I think this has to be a plus. The sign switches, okay? So it should be the opposite of what's ever in there. Okay, so x minus 2 and then y minus 3 because I have a k value of -3. Okay, so let's go ahead and plug this in. So -2 times -2, or -2 minus -2 is -4. 4 minus 3 is +1. -1 minus 2 is -3. 1 minus 3 is -2. When I plug in 0, 0, we get -2, -3, and that's my vertex. Then we get -1, -2, and then plugging this in, we get 0 and 1. So I noticed I have a pattern here, right? Like 1, -2, -3, -2, and back to 1 again, okay? So it goes down, and then it goes back up. Okay, so just plotting these on my coordinate grid. So -4, 1, -3, -2, -2, -3, -1, -2, 0, 1. Okay, and then go ahead and connect your dots, making a smooth curve. Okay, so again, just a reminder, at the 0, 0, this is our vertex. All right, let's look at another example, and we are going to, again, graph using the mapping rule. So our vertex is 1, 4. So our general mapping rule is, so x plus 1. So again, that's the opposite sign of our original question here. So x plus 1, -2, because our a value is -2, y plus the k value of 4. Okay, so our points again, so -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, so we get -1, then 4 times -2 is -8, -8 plus 4 is -4. -1, plugging that in, this time we get 0. -2 times 1 is -2, plus 4 is +2. Plugging in 0, we get 1 and 4, and that's our vertex. Then we're going to get 2 and 2. Then we're going to get 3 and -4. Okay, so again, the 0, 0 is our vertex. I'm going to go ahead and plot 1, 4. I guess I didn't have to do that. -1, -4. 0, 2. Oh yeah, it's upside down, that's why. There's the 1, 4. 2, 2. 3, negative 4. Okay, there we go. All right, so this time, still using the mapping rule, but I have standard form. So again, I have to convert it to vertex form because otherwise I will not have an H and a K. So convert to vertex form. So again, you can use the algebra tiles method if you want, or the algebraic strategy. I will go over both. So I need to evenly distribute 6 x tiles around my x squared, so 3 on each side. And I have 5 ones, 1, 2, 3, 4, 5. I still need 1, 2, 3, 4. So I'm gonna bring in 4 red. And so that's my K, right? So we have x and 3. So y is equal to x plus 3 squared minus 4. And the vertex is negative 3, negative 4. Okay, so then we're going to use our mapping rule. So we have our general rule. So x minus 3, a is just 1, so y, and my k is negative 4, so minus 4. I'm just going to record all of my key points again. All right, so let's go ahead and substitute in. So negative 2 minus 3 is negative 5. 4 take away 4 is 0, so 5 comma 0. So here we get negative 4, negative 3. Here we're going to get negative 3, negative 4. Again, that's my vertex. Negative 2, negative 3, and negative 1, and 0. All right, so we're going to go ahead and plot. So negative 5, 0, negative 4, negative 3, negative 3, negative 4, negative 2, negative 3, negative 1, and 0. Okay, we'll look at one more when A is not 1. So again, we need to convert to vertex form. So I'm going to just use the algebraic strategy. I'm going to move the negative 11 over, and I'm going to take negative 3 out of the remaining 2 terms. So 11 is equal to negative 3. And when I divide these 2 terms by the negative 3, we're left with x squared plus 4x plus something to make my perfect square. So my side calculation, so I'm going to use this 4. So 4 divided by 2. And then square it. So 2 squared is 4. And then please remember to multiply that by our a value, which is negative 3. And I'm going to bring the negative 12 to the side where the 11 is, and the 4 is going to go in that space to make the perfect square. So 11 minus 12 is equal to negative 3 times x squared plus 4x plus 4. Need to factor here, or remember our trick before we square it, that's the number that's going to go in our brackets here. And then I get negative 1, bring my k back over. So the vertex is negative 2 and 1. Okay, so using the mapping rule, I'm running out of space here. Okay, so I have x, y is mapped to, okay, so x minus 2 So remember, it's going to be the opposite of what's here. So that's a plus 2, so this is minus 2. Our a is negative 3y, and then plus 1. That's the k. All right, let's go ahead and write this down. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, positive 2, 4. Okay, then we're gonna sub in negative 2. So we're gonna get negative 4. So we're gonna get 4 times negative 3 is negative 12, plus 1 is negative 11. And so on, let's keep going. So we get negative 3, and negative 3 plus 1 is negative 2. 0, so we're gonna get negative 2 plus 1. I don't need to put the plus. So negative 2, 1. Then we're going to get 1 minus 2, so that's negative 1. 1 times negative 3 is negative 3 plus 1, so negative 2. And last but not least, we get 0, and negative 12 plus 1 is negative 11. All right, so if we go ahead and plot these points, so negative 4, 11 is just off the grid here. Negative 3, negative 2, negative 2, and 3. No, what is that? That's a 1. Negative 2 and 1. Yeah, that's my vertex. Negative 1, negative 2. And then 0, negative 11, again, is just off the graph. All right, that's it for this lesson.